Hello students, welcome back to our channel Diksha Karnataka. So as you all know, mock test 7 has been released. So in this video, I'll be discussing the part 1, question number 1 to question number 30 of chemistry solutions. So if you haven't downloaded the question paper, you can go to our WhatsApp channel. The link of the WhatsApp channel will be there in the description section. So go there, download this paper, solve the questions, and then you can come here to check the solutions. So let us see the first question. The most common oxidation state of cerium. So cerium exists in two oxidation states, that is +3 and +4. So the correct answer for this question will be option number A. Okay. Now let us see the next question. Which one of these is not known? So we know for copper CuI2, this is not known because copper oxidizes I- to I2. Okay. So the correct answer for this question will be option number A. Next. Which of the following coordination compounds the central metal atom obeys the EAN rule? So according to EAN rule, the number of valence electrons in any compound should be 18. Okay. So we can check these options, all the options here. So here FeCN6 has 3 minus charge. Okay. So now we can just calculate what is the oxidation state of iron here. So X minus 6 is equal to -3. So X will be equal to +3. So iron electronic configuration is 4s2 3d6. So if we have +3 in oxidation state, we'll get 3d5. So for iron we have 5 electrons. Then each ligand will donate 2 electrons. So total 6 into 2 we will have 12 electrons. So total our valence electrons will be 17. But according to EN rule it should be 18. So this option is incorrect. Now let us see the next option. Here if you see FeCN6 is in 4 minus charge, FeCN6 4 minus. Okay. So oxidation state of Fe is +2. So electronic configuration of Fe will be in +2 state is 3d6. Okay. So iron has 6 electrons plus each ligand will donate 2 electrons. So 6 ligands will have 12 electrons. So total number of valence electron here is 18. So this compound follows the EN rule. So correct answer will be option number B. Next, which of the following can participate in linkage isomerism? For linkage isomerism, we need ambidentate ligands. Okay, those ligands which have 2 donor sites but only one will donate at a time. So if we know there are certain ligands like CN or NC, then we have SCN and NCS, we have NO2 and ONO. Okay. These are the certain ligands which can show linkage isomerism. So we can see NO2 is there. So correct answer for this question will be option number A. Next, the structure of FeCO5 is, so it is a coordination number is 5. So coordination number 5 have trigonal pyramidal structure. So FeCO5 has a structure of trigonal bipyramidal. So the correct answer for this one will be option number D. Okay. So since here coordination number is 5, we have 3 important coordination numbers. Coordination number 4 can have 2 shapes, that is tetrahedral and square planar. And coordination number 6 will always have octahedral. And coordination number 5 will have trigonal bipyramidal. Next, which of the following descriptions of FeF6 4- is correct about the complex ion? So first of all, it is a octahedral complex. Okay, so the hybridization can be either sp3d2 or d2sp3, right? So all the options are having the same configuration, so we cannot eliminate any option based on the hybridization. Now checking whether it is an inner orbital complex or outer orbital complex, whenever we have strong field ligand, a strong field ligand will give you d2sp3 hybridization, which is inner orbital complex. Now if we have weak field ligand, we will have sp3d2, which is a outer orbital complex. Now here the ligand is fluorine, which is a weak field ligand. So due to this we will have sp3d2 hybridization. So we can eliminate option number C and D. Now when it is sp3d2, it has to be outer electronic configuration. So this will be outer and this one is also incorrect. Now paramagnetic or diamagnetic, we can check here. Fe is in +6. Fe oxidation state is X minus 6 is equal to -4, that is X is equal to +2. So Fe is in +2 oxidation state, that is 3d6. Okay. 3d6 will have unpaired electrons, so it is paramagnetic in nature. Correct answer for this question will be option number B. Okay, now let us see next question. Which of the following ligands will not show chelation? So for this one, the condition it should be having more than denticity should be more than 1. Okay, that means it should be a unidentate. It should not be a unidentate. It can be a bidentate, tridentate, or a hexadentate ligands. So EDTA is an hexadentate ligand. DMG is also a polydentate ligand. This is also bidentate ligand. SCN minus is a monodentate ligand, so it cannot form a cyclic structure and the stability will be less. So the correct answer for this question is option number D. So the condition for chelation is this one should be greater than 1 and it is not applicable for monodentate ligands. It can be possible in all other bidentate, tetradentate or hexadentate. Next question. The magnetic moment of a divalent ion in aqueous medium with atomic number 25 is. So atomic 25 is manganese. So electronic configuration is 4s2, 3d5. So if we draw this 3d5, we have 5 unpaired electrons. So magnetic moment formula is root over of n into n plus 2. So that means root over of 5 into 7. So we'll get root over of 35, which is equal to 5.9. The units is around Bohr magneton. Okay, so correct answer for this question will be option number A. Next question, which of the following elements has the lowest melting point? So melting point and boiling point depends on metallic bonding. So it is depending on the strength of metallic bonding, and the strength of metallic bonding depends on the number of unpaired electrons. So if we have more number of unpaired electrons, stronger metallic bonding will take place. So now if you see, copper has the least number of unpaired electron. It is 3d10 and 4s1. So there is only one unpaired electron in this case. So it will have the least melting point. Okay. So the reason is there is less number of unpaired electrons. So weak intermolecular forces or weak metallic bonding, as a result of which the melting point is less. And if it is asked for maximum is for chromium because it has the highest number of unpaired electrons. Okay. Next, which of the following lanthanides is commonly used? So the commonly used lanthanum is your cerium. It is found in more amount. The abundance is more, so and most widely used. So correct answer is option number D. Okay. Now next question. The trend of basicity of lanthanide hydroxides. So along a period, if we go along a period, what happens to basicity? So we know along a period, the effective nuclear charge increases. Along a period, effective nuclear charge increases. Now this charge increases due to the effect of something called as lanthanide contraction. Okay, very important topic we have discussed. So because of lanthanide contraction, the effective nuclear charge will increase, and as a result of which the nucleus will not allow the central atom to donate electrons. So we can say basicity will decrease. Okay, basicity will decrease. So yes, basicity decreases along the lanthanide series. Okay, and this is due to, the correct answer is option number B. This is due to the increase in effective nuclear charge, which is because of lanthanide contraction. So lanthanide contraction and its consequences are very important topic. There are 3-4 consequences which are generally asked in the exam. So focus on this topic more. Okay. Next question. In a mixture of A and B, the component shows negative deviation when? Okay. So negative deviation comes when the interactions between A and B is stronger than the interaction between AA and BB. Right. So this is because if A and B is having more stronger interaction, then the vapor phase will be less, or the vapor pressure will be less, and the P total will be less than the P ideal pressure. Okay, so the interactions is stronger than AA and BB interaction. So correct answer for this question is option number A. Here you also should know about positive deviation, negative deviation. There are other points of difference, and you have this azeotropic mixture also. Okay. Next question, for which of the following electrolyte lambda m by lambda naught m doesn't hold good? Okay, so this one is limiting molar conductivity. So this formula is only applicable for weak electrolytes. Okay, so we can calculate the limiting molar conductivity of weak electrolytes using the Kohlrausch law. So here the correct answer for this is a weak electrolyte. These are all weak electrolyte. This is a strong electrolyte. So this law is not applicable for this compound HClO4. So correct answer for this question will be option number B. So here you have to remember this Kohlrausch's law is only applicable for weak electrolytes. Okay? All weak electrolytes molar conductivity can be calculated using this formula. Okay? Because of the graph, it doesn't meet the y-axis. So that is why we have to use an indirect method. Okay. Next question, the rate of reaction increases with the rise in temperature because of. So this is the effect of temperature. We have the graph like this, right? When the temperature increases, the number of particles having energy greater than the threshold energy also increases. The number of activated molecules also increases, so the rate of reaction increases. So this is because of increase in the number of activated molecules, increase in activation energy. There is no increase in activation energy with temperature. Okay. Next, decrease in the energy of activation. This is also not there. Increase in the number of effective collisions. This can be also reason. This one also is a correct answer. Okay. So the number of activated molecules increases when both the temperature increases. So the correct answer for this question will be option A and D. Okay. Next question. The rate constant for a first order reaction is given to us, the T75% of this one. So here you have to know one relation, that is T75% is equal to 2 times of T50%. Okay. There is one more relation like this, T99.9% is equal to 10 times of T50%. Okay. These two formulas are used, can be helpful to easy calculation. So first of all, rate constant is given. First order reaction, we can calculate T50%. So T50% will be equal to 0.693 by K. K value is 2 into 10 to the power of minus 2 minute. Okay. Now if you want to calculate T75%, it will be 2 times of this value, that is 0.693 by 2 into 10 to the power of minus 2, and cancel here, we'll get 69.3. Right. So the correct answer for this question will be option number A. Next question. The unit of rate constant for the reaction which has the rate law as this is. Okay. So for this, first of all, we should know the general formula for rate constant. So K is equal to moles to the power of 1 minus n liter to the power of n minus 1 second inverse. Now order is the sum of the powers of the concentration terms. So here H2 power is 1, NO power is 2. So I can say the order total is 3. Now substitute this 3 here and then calculate. So moles to the power of 1 minus 3, L to the power of 3 minus 1 second inverse. So we'll get mole minus 2, liter 2 second inverse. So correct answer for this question will be option number C. Okay. So rate constant is very important term again. How to calculate this one and half-life method is an important topic. Prepare them. Next question again from kinetics. Half-life of a first order reaction is 10 minutes. What percentage of the reaction will be completed in 100 minutes? Okay, this is very good question. The relation that I have told you, T99% T99%, 99.9% is equal to 10 times of T50%, right? So now if you see 100 minutes is 10 times of half-life here. If I write 10 into 10 minutes, that is the time half-life here. So that is 100%, right? So that means 100 minutes, that means in 100 minutes how much will be covered? T99.9%. You need not solve it at all, right? So the correct answer for this question is option number C. Okay, now next question. Limiting molar conductivity of NH4OH. Okay, so this is a weak electrolyte. How to find out? So NH4Cl plus NaCl. No, there is no OH at all, right? So we can ignore this option. Now this is NH4Cl, this is NaOH. So from here we will get NH4OH plus NaCl. Then you will subtract minus NaCl to get NH4OH, right? So the correct answer for this question is option number B. Okay, next. The equivalent conductivity of N by 10 solution of acetic acid at 25% is this one. What will be the degree of dissociation? Lambda m is given. Okay. Now see here, degree of dissociation formula is lambda m by lambda naught m, right? Now for this one, for acetic acid, equivalent conductivity and molar conductivity will be equal because N factor is 1. So we can use it alternatively. So lambda m value is given to you 14.3 and lambda naught m is given to you 390.71, right? So sorry, 390. So just divide this and into 100, percentage is there, so into 100. So if we solve this, we'll be getting around 3.66%. Okay, just check the calculation. So the correct answer for this question is option number A. Okay, next question. The maximum amount of solid solute that can be dissolved in a specific amount of a given liquid solvent does not depend on. Okay, so there are two types of thing. What is solubility of liquids, solubility of solid in liquids and solubility of gases in liquids. Okay, so solubility of solids in liquids depends on temperature and does not depend on pressure. Okay, but solubility of gases in liquid depends on two factors, that is temperature and pressure, right? So here the question is about solid solute, right? So it doesn't depend on pressure. Why? Because solids are incompressible. So the correct answer for this question is option number C. Okay, next. The value of Henry's law constant Kh increase with increase in temperature, decrease with the increase in temperature, remains constant, first increases and then decreases. So see here, we know about solubility. Kh is inversely proportional to solubility. Okay. Now similarly, we have if solubility, if temperature increases, then solubility will decrease. Okay. If temperature will increase, solubility will decrease. So if solubility will decrease, then Kh will increase, right? So that is why we can say there is an increase in Kh value with the increase in temperature. So when we increase the temperature, solubility of the gas decreases. If the solubility of the gas will decrease, the Henry's constant will increase, right? So that is why it increases with the increase in temperature. Option A is correct. Next question. Osmotic pressure of a solution containing 2 gram dissolved protein per 300 ml of the solution is 20 mm of Hg. At 27 degrees Celsius, the molar mass of the protein is. So from the solutions chapter, or osmotic pressure direct formula, we have this formula pi is equal to CRT. CRT, here C is molarity. So we can write given mass by molar mass into 1000 by volume into R into T is equal to pi. The question has asked to calculate the molar mass. So we can just arrange the equation. Molar mass is equal to the given mass by osmotic pressure into 1000 by volume into R into T. Okay. Now let us substitute the values here. Here mass given is 2 gram. Okay. Pi given is 20 mm of Hg. Then we have 1000 and volume is 300 ml. Then R value and temperature given is 27 degrees Celsius. So convert that is 300 Kelvin. So now if you solve this for molar mass, we'll be getting somewhere around 6239. So the correct answer for this question will be option number B. Little lengthy calculations, you can do the calculation and check once again. The answer should be coming somewhere around 6000. Okay. So next question. Plant cell shrinks when it is kept in a, so this is osmosis again question. So when it is kept in hypertonic solution, the cell will shrink. Okay. If hypotonic, then the cell will swell. Okay. So correct answer is option B here. Now let us see the next question. In the given set of reactions 2-bromopropane, we have to find the product Y and its IUPAC name. So the question is like this. We have 2-bromopropane and then it is treated with AgCN. Okay. So we will get here NC, right? Now if you do lithium, that is with lithium aluminum hydride, it will undergo reduction. So we'll get NH and CH3, right? So this is a secondary amine. So we have, this is propanamine, this is N-methyl. So N-methyl propane 2-amine. This one is also correct, isopropyl if you write, but isopropyl is a common name. It is not a IUPAC name, okay? So the correct answer for this question will be option number B. N-methyl, then at second position we have propanamine. So next question, Lucas test is associated with. So Lucas test is for alcohols, primary, secondary and tertiary alcohols. So the correct answer for this question is option number D. So using Lucas test we can identify, or it is a test to differentiate between primary, secondary and tertiary alcohols. Okay. Next question, which of the following represents the correct order of relative acidic strength? So acidic strength and basic strength questions are very common. So here you have to remember, if any electron withdrawing group is there, acidity will increase. If electron donating group is there, acidity will decrease. So first of all, if you see all the options, we have these molecules where chlorine is present. Okay, chlorine has minus I effect, so it can stabilize the conjugate base and acidity will increase. So it has to be the first one, so we can eliminate all other options. Option B should be the correct answer. We can check other options also here. Now here in these three molecules there is no chlorine, right? So there is no effect which can stabilize the conjugate base. Then what does it, the factor depends on the hydrocarbon part, which has plus I effect, right? The smaller the hydrocarbon part, less is the plus I effect, more is the stability. So that is why HCOH, then CH3COH, and then C2H5COH. So the correct answer will be option number B. Next, which of the following has the maximum stability? Okay, so stability order is, we know for carbocation it is 3 degree, 2 degree, and 1 degree. And if there are any two like same degree carbocation, then we have to check whether it is stabilized by resonance, and then hyperconjugation, and then inductive effect. So here this carbocation is secondary, this is also secondary, this is primary, and this is secondary. So anyway, we can eliminate option number C. Now checking option A, B, and D. Here this is also secondary, this is also secondary, but here you can see there is something resonance stabilization is there, right? This oxygen lone pair can be donated here and can stabilize the carbocation. Okay, so the correct answer for this question will be option number B. Okay, fine. Now let us see next question. Which of the following reactions is not an example of electrophilic substitution in benzene ring? Okay, so if we have Cl2 and AlCl3, that is your Friedel-Crafts alkylation, sorry, this is addition of chlorine, halogenation reaction, that is also electrophilic substitution. This is Friedel-Crafts acylation, again electrophilic substitution. Next, this one, 3Cl2 sunlight, addition of water. This is a free radical mechanism. It is not a electrophilic substitution, right? So the correct answer for this question will be option number C. Okay, now let us see the next question. The equilibrium constant at 717 Kelvin for the reaction is given. So this is our reaction, H2 plus I2 gives 2HI, right? So the equilibrium constant for this one is 60. Now the equilibrium constant for the reaction 2HI gives H2 plus I2. So what has been done in the reaction? The reaction is reversed. Okay, there are three important points here you must remember for chemical equilibrium. When a reaction is reversed, the equilibrium constant becomes 1 by something. Like for example, if we have a reaction A gives B, its equilibrium constant is K, right? Now if the reaction becomes B gives A, then the equilibrium constant for this reaction is 1 by K. This is first point. Now second point is, if you multiply the whole reaction with 2, okay, then the equilibrium constant here will be K square. Okay, the new equilibrium constant will be K square. Now third one is, if we reverse the reaction, this one, and if you multiply any factor, and if you multiply with 1 by 2, okay, you multiply the whole reaction here, then it will become K to the power of 1 by 2, right? So these are certain things that you must remember. And one more thing is the fourth one, if two reactions are added, okay, A gives B suppose and B gives C, okay, this is K1 and this is K2. Now if the two reactions are added, we will get A gives C. So the equilibrium constant for this reaction is K1 into K2. Okay? So these are some important points from chemical equilibrium. So in this reaction, what has been done? Only the reaction is reversed. So the K value will become inverse. So we will get 1 by 60. So 1 by 60 is 1.6 into 10 to the power of minus 2. So the correct answer for this question is option number A. Okay, now let us see the next question. The correct order of electronegativities of N, O, F and P. Okay, so you can arrange them in the periodic table. First we have nitrogen, oxygen, fluorine and then phosphorus, right? So this is along a period and this is along a group. So along a period what happens? Electronegativity increases. So fluorine will be most electronegative, so we can eliminate option B. After fluorine it will be oxygen, then it will be nitrogen and then the phosphorus. Okay. So the correct answer for this question will be option number A. So these were the first 30 questions of mock test 7. I hope you have solved it. If you have any doubt in any question, please comment down. The link of the WhatsApp channel will be there in the description section. Go there, download the question paper and solve it. Thank you.